In this lesson, we're going to be looking at pedigrees. So, a pedigree is a diagram that illustrates the genetic relationships among a group of related individuals, and it uses a set of standard symbols. So, a square, which is blank, not filled in, represents a normal male, and a circle that is not filled in is a normal female. And then, for whatever condition or trait the pedigree is examining, if the symbols are colored in, that tells you that that individual is affected by whatever trait it is that you're looking at. Individuals who are married or who have had children together are connected by a straight line. Okay, so this is a normal male married or have had children with an affected female. And if they have children, the children are added below the connection. So here's an example of a pedigree. So you can see on the left, there are Roman numerals, and those indicate the generations. And then the individuals are identified by their generation number and their order number in that generation. And the individuals are numbered from left to right. So if we were to look at this individual right here, this is a male, it is not affected, and its numbering would be 2, 3. That's individual 2, 3. So if we just go over some examples, so what is the relationship between individuals 1, 1 and 1, 2? So that's these individuals. Okay, so we can see that because they are connected, they're either married or they've had children together. How about the relationship between individuals 2, 2 and 2, 3? So that's these ones. So those are 2 males, so those are brothers. And what is the relationship between individuals 2, 4 and 3, 1? So that's those 2 individuals. So that is a mother and a daughter. The mother is unaffected and the daughter is affected. So when you have a pedigree, by looking at it, you can figure out whether the condition that's represented in the pedigree is because of a dominant allele or a recessive allele. So first of all, if a disorder is recessive, you're going to look for certain clues. So the first is that 2 unaffected parents are able to have affected offspring, right? So we know that 2 parents that are heterozygous can have a homozygous recessive child, right? So that can occur if the disorder is recessive. But if you have 2 affected parents, all of their offspring would have to be affected, right? Because if the parents are affected, they are homozygous recessive, which means the only option is to have homozygous recessive children. However, if the disorder you're looking at is due to a dominant allele, there's a couple different situations. So in this case, at least one parent of an affected individual must display the trait because the allele had to come from somewhere, right? So you could have this situation where the offspring, which is the heterozygous capital A, small a, they had to get that capital A from somewhere, so at least one parent would have had to have been affected. And the opposite of when it's recessive, in this case, if you have 2 unaffected parents, they can only have unaffected offspring. It's the same cross, but for this time, it's these people are unaffected. The other thing is when the disorder is dominant, it usually appears more often and in every generation. So if we look at this example pedigree we've been looking at, let's figure out if it's recessive or dominant. So if we look at those 2 situations, we see that we have unaffected parents making affected offspring. And the only way that that can happen is if the disorder is recessive. So in this case, this pedigree is showing a recessive condition. So the other thing you can figure out from a pedigree is whether the trait you're looking at is on an autosome or whether it's on one of the sex chromosomes. So is it an autosomal condition or a sex-linked condition? So we already know that this disorder is recessive. So now we're trying to figure out, is it autosomal or is it sex-linked? So if it is sex-linked, then you're looking for a few things. So the first thing is any affected female must have an affected father. Okay, so an affected female, because it's recessive, is going to be X little a, X little a. Well, one of those X little a's would have had to come from the father, which means the father would have had to be affected because he only has one X chromosome. Additionally, any sons of an affected mother must also be affected. Okay, an affected mother is going to be X little a, X little a, and she's going to have to give one of her X chromosomes to her son, and so it's going to be an affected X chromosome, and then the father gives the Y, so the son will also have to be affected. So if we look at this pedigree, we have an affected female here, but the father is not affected. So that goes against that first sort of rule there, that any affected female must have an affected father. So that means that this is not a sex-linked condition. It is an autosomal recessive condition that this pedigree is showing. So once you've established what it is, then you can apply a genotype to each individual in the pedigree. So we know it's autosomal recessive. So I'm going to use the letters A just as a random letter to represent it. So because we know it's autosomal recessive, we know that these affected individuals must be little a. And we know that their parents must be heterozygous in order to give them the little a. And then these last two individuals, we can't fully assign a genotype. We don't have enough information. So they definitely have a capital A because they're not affected, but they could be heterozygous or homozygous. We don't have enough information to figure out which. So now let's talk about, what if it was a dominant disorder? How do we figure out whether it's autosomal or sex-linked? So in order to be sex-linked dominant, all daughters of an affected male must have the trait, right? So now it's dominant, so an affected male is going to be X capital A Y, and that father is going to have to give his X chromosome to his daughter. So he's going to have to give an X capital A, which means the daughter will also have to be affected. And then any affected male must have an affected mother. So an affected male is the X capital A Y. Well, that X capital A had to come from the mother, which means the mother must have been affected. So let's look at this pedigree. So if we look at this, these parents and child, so first we need to figure out, is it dominant or recessive? Okay, so this is, if you notice, this is the opposite condition of what we were looking at in the last pedigree, right? We have two affected parents who have an unaffected offspring. And so that tells us that this has to be dominant. And we have another example over on the side. Okay, so this is a dominant condition because otherwise, if the two parents are affected and it's recessive, all the children would have to be affected, but they're not. So now we're going to look for clues as to whether or not this is a sex-linked dominant condition. So we're going to look for the affected males. So there are 3 of them. And so it says, all daughters of an affected male must have the trait. So if we look at the affected male in generation 1, you can see that they have one daughter and that daughter is affected. And that's actually the only daughter in the pedigree. So that one holds. Any affected male must have an affected mother. So our affected male in generation 3 has an affected mother in generation 2, and also our affected male in generation 2 has an affected mother in generation 1. So all of the clues that this is a sex-linked condition hold true for this pedigree. So it is most likely sex-linked dominant, but it actually could be autosomal because it would work autosomally as well. But because you're seeing this pattern with males and females and daughters and mothers and sons, then it is likely sex-linked, but not necessarily. So then again, once you figure that out, okay, it looks like this is a sex-linked dominant condition, or at least we can't rule that out, then you can figure out all of the genotypes for all of the individuals. So if we start with the unaffected, because they're the recessive ones, so we have an unaffected male, which has the recessive allele, and there's another unaffected male. Any of the affected males are going to be X with the capital AY. And now to figure out the females, well, we know that they're affected, which means they must have at least one dominant allele. And if they've had unaffected children, then they have to be heterozygous, right? So this mother would have to be heterozygous in order to give that recessive allele to that unaffected son. Similarly with that mother. The last female that we have over there, we don't know for sure what their other allele is. Okay, they could have gotten that dominant allele from the father, and then they could have gotten either a dominant or recessive from the mother. So we don't know without any more information. Okay, so those are pedigrees, and so those are the things you'll need to, so you'll need to be able to draw pedigrees, figure out if they represent a dominant or recessive condition, and whether they most likely represent an autosomal or sex-linked condition.